Hello, this is Prospector Rick of Geotech Analytical, and this will be a short discussion on geochemistry and the sodium thiosulfate transport of gold and silver. When basaltic oceanic floor is subducted, it is compressed and heated. This process drives off the water and it leaves the salt, which is then calcined. That means it's heated, the chlorine is drove off, and it reduces down to sodium. The sodium, in turn, then reacts with water produced within the melt, and thus reacts creating sodium hydroxide, commonly known as lye. This reacts with sulfur produced from sulfur dioxide in the melt, reacting with water creates sulfuric acid. There's a sulfur component there. It reacts with the sulfur, converting into sodium thiosulfate. Sodium thiosulfate is well known for its ability to dissolve silver and gold. It's used as a leach in the mining industry on ores and ore concentrates especially. As this sodium thiosulfate and sulfuric water and acid mix goes towards the surface, it dissolves all the silver and gold through the rocks that it passes through. As it works its way to the surface, if there's a sudden change in pH, it will precipitate gold. And that's a big one. There's also a sudden change in pressure if it goes into any kind of overlying gap. And the sudden decrease in pressure will cause gold to precipitate. One of my favorites is where this solution passes through a ground mass containing lots of iron, because in this process the sulfuric acid dissolves iron, creating ferrous sulfate, and then refining and leaching that is a precipitant for gold. So where this naturally occurring sodium thiosulfate complex carrying gold and silver passes through ferrous rock, meaning rock containing iron, it will precipitate the gold in that zone through the rock where it's passing, creating high-grade native gold or micron gold dispersed through whatever minerals drop out of solution due to temperature and pressure changes. Hope this has been helpful.